Hi, very good morning to everyone. Assalamualaikum. My name is Wira Hidayat bin Muhammad Saad. I am a senior lecturer in Faculty of Electrical and Electronic Engineering, University Technical Malaysia Melaka, located in Durian, Tunggal, Melaka, Malaysia. This presentation is prepared for MUCET 2021. The title is Implementation of Multiple Face Detection for Surveillance System. You can go through my website to know me better, and you can also look into my faculty website to look into what is happening currently in our faculty. And my research groups is actually machine learning and signal processing, MLSP. Machine learning ada set and centers of excellence for advanced in telecommunication engineering. You can go to our COE website to look further on our website too. So let's go uh, straight away into our presentation. So let's look into what is the common issues in the CCTV, the problem statement that causing the reason why that we are doing this research. So there is a few problems in the camera. The CCTV unable to capture individual face clearly, and issues of the focus or static point of the lens. The focus of the lens is focused on somewhere that is not in the face of the So the lens is not focused on the face of the criminals, and then playback blur and identity of the people is unclear. And then if you install the camera that is very high resolution, uh, then it will simply cost a lot of memory in order for you to save the good qualities of face information. So So that is the mostly current issues. But before we go further, details in the project development. So let's we talk about a little bit of surveillance system. Then there is a PTZ. PTZ is a type of camera that we can control the pan, tilts, and zooms of the cameras. And then the face detection. So there is a lot of algorithm on the face detection. So basically, the face detection is able to identify the human face in digital image in real time and recognize by locking the features of eye, nose, and lips. And then there is the concept of autofocus that will be we're going to talk a little bit on this project. So the autofocus is to improve the image quality on the specific area, focus on the interest area without any interaction. And then we have two type of focus, which is the active autofocus, measure distance of object in the image, adjust the optical system for the focus, measure the distance by using the ultrasonic sound, and etc. And then we have a passive autofocus, analyze the image, enter into the optical system and determine the correct focus, and then two type of contrast, detection, phase, and phase detection. Okay? So this project is actually aimed to configure the PTZ IP camera or manual navigation to apply the face detection algorithm in the camera view and instruct the camera to focus on the face and to evaluate the system performance for accuracy and reliability. So we have three things that we want to achieve on this project. So basically, simply for this, we only use a laptop with the LabView inside, and then we are using a PTZ camera, the wireless PTZ camera, and then we have a wireless modem too. So every all of the device is connected to the wireless modem lah, same network. So this is a methodology of the project. Basically, we separate this into two. How we develop the project, and then how the system work when we deploy it. So basically, if you look at here, we need to try to from the pre-available algorithm of face detection, we try to create the DLL file out of the algorithm, and then from those DLL file, we try to put it into our LabView code, and the LabView are able to interact with the camera. We try to configure the camera by using some of the LabView tools, and then the LabView are able to interact with the cameras and things and stuff. And then how is being deployed? So the camera will capture the scene, live stream the scene, and then detection of the face from the scene, and then face feature extraction, detect the eye, and then read the face. And if let's say they can detect the face, they will do the autofocus based on the location of the face. And then we have a violent Jones method. So this is a method that we try to look up into the pre-available things in online, and then we, by using the Visual Studio, we try to create the .dll file, and those DLL file will be used inside of the LabView uh, uh, block diagram. So so this manager has a few different steps from the image, and then we apply the highlight features, and then integral image, adapting, boosting, cascade classifier, and face or not face. So that is based on the block diagram. So this is all the process inside of the block diagram. So this is the LabView graphical code. So inside of this LabView graphical code, there's a few things that we use to uh, read the image, to read the image from the camera, and then so the DLL file is inserted into here. The image acquisition from the camera is setting up through here, and then in here we will convert into the most suitable image to be processed by using the algorithm, and the algorithm continue and making a decision whether it can be detected or not. So the result, speed of detection, in terms of speed of detection, time processing to detect the face is about uh, 115 milliseconds, and average time to detect the face immediately is very fast lah, I would say. Accuracy test, position of face, movement of the face, obstacle of the face. So we have a few different exercise that we try to test the the best performance on the algorithm based on a few different tests. So we try to look into the position of the face, and we found that the accuracy is about 71%. And then uh, while it's moving, is all detected. And then obstacle on the face. If we put some of the obstacle on the face, we do with several different numbers of image, and we found that 86% of the time, 86, we found that the accuracy is about 86%, and daytime and night infrared condition. So basically, when we close the light, so the infrared light will be detected, will be turned on. So it's so far, if the position of the face can be detected in the daylight, it can also be detected in the infrared mode as well. So based on this, this is what we can conclude. So we'll be able to configure the preset camera, IP camera, navigation system work well, face detection work excellent, and autofocus to the face is done by using the curve. So what does that mean is that basically this is an IP camera. Whenever that we they have their own interface of the IP camera. So whenever that we click through the interface given by the manufacturer, we will try to look what is the curl code that has been generated by clicking every single inch of the button. So we try to generate those code and put it into LabView in order for it to work as it should lah. So that's it from me for 8 minutes of presentation. If you have any question, you can always come and contact me at any time, and I will try to answer the question. Uh, I will try to answer any of the question that given by you guys. So thank you very much.